folks, Ms. Gosling here with the very last video in our Work, Power, and Energy series. In this video, I'm going to be using the principle of conservation of energy in order to determine how an object's potential kinetic energy and speed change over the course of a journey. So without further ado, let's go ahead and start with the problem. Below is a picture of a roller coaster. The roller coaster car starts at rest at point A. At points A, B, and C, calculate the potential energy, kinetic energy, and velocity of a 1,000 kilogram roller coaster car. So let's go ahead and start with point A, because A, that's the place where we start, and B, that is the simplest point. And before I even get started with the problem, I want to go ahead and write out the equations that you need to know. So first, we have kinetic energy equals 1/2 mv squared. We have potential energy equals mgh. We have our total energy, which is going to equal Ke plus Pe. And finally, we know that our energy at point A is equal to our energy at point B, which is equal to our energy at point C. And that is just the principle of conservation of energy. This last equation is just the principle of conservation of energy in mathematical form. So let's start at point A, because again, point A is the simplest. So I'm going to go ahead and start down here. So, at point A, my givens are the mass of the cart is 1,000 kilograms. G is 9.8, but I'm going to go ahead and round that to 10 meters per second squared. And the speed of my cart is 0 meters per second, because as you can see in the problem, the roller coaster car starts at rest. Now, I have to figure out my unknown. And my unknown here is going to be the potential energy of the cart, one of our givens. So I'm going to just go ahead and circle that, and there we go. We have figured out the initial velocity of our cart. Now, let's go into my equation and determine the potential and kinetic energy of my cart. So the potential energy of my roller coaster cart is given by mgh, and the kinetic energy is given by 1/2 mv squared. And I don't have to do anything else here because my unknowns are already isolated, which means I can move on to the substitution phase. And I'm going to go ahead and I'm going to start with potential. So the potential energy of my cart is its mass times little g, which again is 9.8, but I'm rounding to 10, times the height of the cart off the ground, which is also 10. So I am ready to go ahead and do my solution for potential energy. And I will find that my PE is equal to 1,000 times 10 times 10, or 100,000 joules, which again I could rewrite as 100 kilojoules. So I've gone ahead and I have solved for my potential energy. Now, I'm going to solve for my kinetic energy, which is going to be equal to 1/2 mv squared, or 1/2 times 1,000 times 0 squared, which is nice and easy because that means that our kinetic energy is just 0 joules. And there you have it, guys. I have solved for everything that I need for part A. So I'm ready to move forward to point number B, or I guess point letter B. Let me go ahead and switch to blue for that. So at point B, my givens are, again, the mass of the cart is 1,000 kilograms. G is 10 meters per second squared. My height here is 0 meters off the ground. And I also know that my energy at B is equal to my energy at A. And my energy at A is 100,000 joules plus 0 joules. So I know that my total energy at point B is 100,000 joules. And I know this because of the principle of conservation of energy. I'm going to go ahead, I'm going to write that for y'all, because that is what is key here. The total energy at point A is the same as the total energy at point B, which is the same as the total energy at point C. So that is going to be all of my givens. And now I'm really ready to move forward into my unknown. And what I'm going to do is I'm going to actually go ahead, I'm going to switch to blue, which I didn't do earlier. So my unknown at point B is, again, PE equals question mark, KE equals question mark, and V equals also question mark. Let's go ahead and work through this. So let's write down my equations. I know that PE is equal to mgh. I know that my energy at B is equal to my potential energy at B plus my kinetic energy at B. And I know that my kinetic energy is equal to 1/2 mv squared. And again, we're looking at our potential energy at B, our height at B, our kinetic energy at B, and our speed at B. And just looking at this problem and at this picture, we can see that from point A to point B, all of our energy has been transformed from potential energy into kinetic energy. And the way to prove that to you guys is to go ahead and substitute in to my potential energy at B equation what I know. So my potential energy at B is mgh, so 1,000, times 10, and times my height at h, which is 0. Because as you can see, B is right at my 0 line. Now remember, guys, you can decide where you want your 0 to be. For me, this is what made the most sense, because B is the lowest of my 3 points, and therefore is the easiest place to give 0 potential energy. So what I'm going to say is that my potential energy at B is 0 joules. Now I can move forward and solve for my kinetic energy at B. I know that my total energy at B is 100,000 joules. That is equal to my potential energy at B, which is 0 joules, plus my kinetic energy at B. That 0 joules is going to go ahead and disappear, and I will find that my kinetic energy at point B is 100,000 joules, or again, 100 kilojoules. Finally, I'm ready for my very last step, which is to go ahead and figure out my speed at point B. And before I do that, I'm going to go ahead and just add solve to the same category as substitute, because quite frankly, we're kind of doing both at the same time. So finally, I am going to use my last equation, KE at point B equals 1/2 m times my speed at B squared. And I can go ahead and plug in all of my numbers. And before I do that, I'm actually going to go ahead and just isolate my speed at B, because that's going to make it a lot prettier. So my speed at B is going to equal 2 times my kinetic energy at B divided by my mass of my car, and we're going to take the square root of that. And plugging in my numbers, what I will get is it's 2 times 100,000 divided by 1,000. And again, I'm going to go ahead and take the square root. Now, if you don't believe me on this, you are welcome to either A, put in your numbers first, or B, go ahead and try and solve for the speed of B yourself, isolate the variable on your own, and put in all of your numbers. And when I stick all of that in the calculator, I will get that my speed at point B is 14 meters per second. So I've gone and I've solved for point A, and I've solved for point B, and what I'm going to do is I'm going to erase some of my work and just write out my solutions. So let's go ahead and do that. So at A, V equals 0 meters per second, Ke equals 0 joules, and Pe equals 100 kilojoules. At B, V equals 14 meters per second, Ke equals 100 kilojoules, and Pe equals 0. And now I'm ready to erase everything else and move forward into point number C, my last point on my roller coaster. Stay with me, folks. We're almost done with this video. So let's go ahead into the video. Point C over with. So at point C, my givens are the mass of the coaster is 1,000 kilograms. G is 10 meters per second squared. My total energy at C is equal to 100,000 joules. Again, 100 kilojoules. And my height at C is 5 meters. My unknown here is, as always, Ke, Pe, my potential energy, and my speed. And I'm going to use the same equations that I used for point B. So I'm going to use Pe equals mgh, Ke equals 1/2 mv squared, and E at C equals Pe plus Ke. And for my last set of things to do, I need to substitute and solve. So let's go ahead and do that. Sub and solve. And I'm going to start, as always, by solving for my potential energy. Now, the reason I'm doing this first is because that is the only kind of energy that I have all of my information for, so it's going to be the easiest thing to solve. So my mass is 1,000 kilograms, G is 10 meters per second squared, and my height is 5 meters. And so what I will do is I will multiply that out, and I get that my potential energy is 50,000 joules, or 50 kilojoules. So there I have finished my first unknown for C. And I can move forward and find my kinetic energy. So my kinetic energy can be found using my third equation, EC equals PE plus KE, both at point C. So my kinetic energy is equal to my total energy minus my potential energy, or 100,000 minus 50,000, which gives me a kinetic energy of 50,000 joules. And I'm now ready to do my last thing and figure out my speed at point C. And to do that, I am going to use my kinetic energy and my kinetic energy equation, and I will find that 50,000 is equal to 1/2 times 1,000 times my speed squared. I'll go ahead and divide both sides by 1/2 and 1,000 and take the square root. And when I do that, I will find that my speed is 10 meters per second. And there you have it, guys. I have solved for my potential energy, kinetic energy, and speed for each point on my roller coaster. And one thing I want to point out here, guys, is that you want to start by working with your energies. So start by finding your potential energy, use that and your total energy to figure out your kinetic energy, and then finally use your kinetic energy to figure out your speed. And that's going to be very, very key for solving these problems. And that's all I have for you guys. So go ahead, try yourself. Happy solving!